Hello everybody, welcome to Forces Unit 1. This is lesson number 2. This is about scalar and vector quantities. For this lesson you're going to need something to write with, a pen or a pencil, something to write on, a piece of paper or maybe a book, exercise book. If you want to, you can use a calculator for some of the calculations, although they are very easy. You should be okay without one if you don't have one. If you haven't got those things, go and get them now and then hit play when you're ready to start. Okay, let's start as we always do with a little mini recall test on stuff that you've done before. So this is stuff from lesson 1. So just write down the answers, pause the video. When you're ready to go through the answers again, hit play. Okay, let's have a look then. These are simply the things we went through last lesson. The answers are the resultant force is a single force that can replace several other forces. It's the single force to replace them that's the important bit. Resultant force will cause something to change speed or change direction. If there isn't a resultant force, it doesn't change speed or direction. Do remember, you could have a speed of 0. So if there's no resultant force, it will stay at a speed of 0. It will continue to not move. Okay, introduce you to a few key words now. Quantity. This is something you can measure. Anything you can measure is called a quantity. For example, mass, time, force, distance, angle, and temperature. Anything you can measure at all, anything you might use some kind of measuring instrument for, or a ruler, or anything like that, that is a quantity, something you can measure. Some quantities don't have direction, they're called scalar quantities. They just have a value. Let's have a look at a few of these. So, mass does not have a direction. It's perfectly good, perfectly correct to say something has a mass of 5 kilograms. A mass of 5 kilograms less is meaningless. It doesn't make sense, so that would be wrong. So it's definitely just the value of 5 kilograms. Likewise with time, you can have time of 23 seconds. That is perfectly right, perfectly correct. A time of 23 seconds just does not make sense. So what I'm saying is they are scalar quantities. You only need the values of them for it to make sense. So those two bits in the boxes then that we've just gone through, write them down in your book as key learning ideas. Pause the video. Once you've got them written down, press play again and we'll move on to the next bit. Okay, time to move on then. Doing calculations with scalar numbers is really, really easy. All you've got to do is use the numbers. So 3 really easy questions. Pause the video, just write down the answers, and I'll go through them when you press play again. Okay, I said these were really, really easy. So a man has a mass of 20 kilograms. A lady has a mass of 12 kilograms. What's the total mass? Well, it's quite simple. You just add the two numbers together. So you should have had 20 plus 12 equals 32 kilograms. Really easy. The unit there, kilograms, is extremely important. If you haven't got the kilograms, you've got the question wrong. Likewise, the boy runs for 20 seconds, rests for 5, and then jogs for 6. Just add the 3 numbers together. 20 plus 5 plus 6 makes 31. You could have 31 seconds, or you could do 31s. Either would be totally correct. If you don't have one of those units in, then it is wrong. Last one, saucepan of water starts at 20, heated by 10 degrees. Again, just add them together. 20 plus 10 equals 30. Don't forget the unit degrees Celsius, degrees C. That is important. As I said, they were really, really easy. So scalar quantities, they don't have a direction. You just include the numbers. Now, sometimes direction doesn't matter. Let me explain what I mean then. So Dave must be a distance of 2 meters from Paul. The direction doesn't matter. You can be 2 meters east, west, north, south. somewhere, anywhere in between. The direction isn't important. If you're 2 meters away, you're 2 meters away. Likewise, Michael is riding his bike at 20 meters per second. He doubles his speed to 40 meters per second. Doesn't matter which way he's going, he still doubles his speed. Direction doesn't make any bit of difference. So distance and speed are scalar quantities. The direction does not need to be included in calculations. Add that thing in the box to the ideas that you've already written down this lesson. Pause the video. So there are the 3 key ideas that we've learned so far today. Let's have a look at some more questions. So write the answers in your book, pause the video, I'll go through the answers in a moment. Okay, once again, very, very easy. Just put the numbers in. So John has a distance of 2, who's further away, so he's 7 times further away. So you should have had 2 times 7 equals 14. And don't forget the M, or you could have written out the word meters as well. So the unit is important here. And George is driving his car at a speed of 10, 3 times the speed when he changes gear. So it is 10 times 3, 30 meters per second. If you got those right, well done. Sometimes direction does matter. Have a look at this little problem. See if you can work out what the answer is. Pause the video, and I'll go through it when you press play again. Okay, let's go through this then, see what you might have done. I find the best way to solve these types of problems is to draw a little diagram of how they may have been laid out. So it could be simple answer. I imagine quite a few of you have got them laid out like that. But it could be, although John and Paul are 2 meters from George, they may be next to each other like this one here. So that may be your answer. It may be they've arranged themselves in some kind of triangle, which is probably the most efficient way of doing it. But the question doesn't actually say that, does it? It doesn't say, give you a clue which of these is right. So the problem is, there's 3 possible answers. They could be 4 meters apart, they could be 0 meters apart, or they could all be 2 meters apart. So the problem is, the question isn't clear. The question doesn't give you enough information to be able to come up with a single answer. The direction does matter. You do need a way of putting the direction into calculations. Otherwise, you get the situation where you could get a GCSE exam question, ask you a question, and there could be lots of different correct answers. And that doesn't really work very well in exams. Okay, still with our things, sometimes direction does matter. Let's do another problem now. This is Amy and Mary. So, how long is it before they meet? A few details there. Pause the video, press play, and I'll go through the answer. Let's have a look at this answer then. As always, turn it into a diagram. There's several different possibilities here. I've drawn 3 here. So if this was Amy on the left and Mary on the right, then in this one, they never meet. But in the second diagram, it's 10 seconds away from meeting, and in the bottom one, they never meet. So once again, the question's not very clear. There could be several answers. So what we need to do is come up with a way of being able to put the direction into calculations as well as just the value. 2 new key ideas for you now. If you've got a distance, but it also has a direction, we give that a new name. We call it displacement. If you've got a speed, but it has a direction, and the question includes a direction, we call it velocity. So jot those down, add it to your list of key ideas for the lesson. Okay, let's move on to the next bit then. There's a new key idea for you, something called a vector quantity. We've already gone through this lesson and we talked about scalar quantities, where it's just a quantity which has a value, a size, we call that a magnitude. A vector quantity is similar, but it has direction. Now, we've already talked about displacement and velocity. They are called vector quantities. Knowing that information, you should be able to carry out the next task. So, you've got all these quantities down the bottom. Quite simply, sort them into scalar quantities. That's the one where you only have a size or a magnitude, or vector quantities where they include a direction. Copy down the table into your book, write them in the right column, pause the video, and we'll go over the answer in a moment. Let's see how you got on then. Mass is a scalar quantity. You can have 5 kilograms. 5 kilograms east, west, north, or whatever is meaningless. It's a scalar quantity. Distance, if you're 2 meters away from someone, you're always 2 meters away. Doesn't matter what direction you are in. Likewise, if you're going at 50 miles an hour for speed, you're always doing 50 miles an hour. The direction doesn't matter. You're still going at that speed. Temperature, you can have 36 degrees Celsius. 36 degrees Celsius west is meaningless, just has a value. It's a scalar quantity. And likewise, time. 4 seconds is 4 seconds. You cannot have 4 seconds west or anything like that. So all of these things just have values. They don't have directions. They are scalar quantities. Look at some vector quantities. Force. Force is a vector quantity. If you remember back to last lesson when we did all those tug of war diagrams, every force had a little arrow showing which direction the force was acting. So it had a value or a magnitude, and it had a direction. We've already said previously, if you've got a distance associated with the direction, that is called displacement. We can do some more work on that later. And velocity is speed in a certain direction, so that is also a vector quantity. And one we haven't talked about, will come in other lessons, acceleration is a vector quantity. Well done if you've got all of those right. So one last definition then to add to your list. Vector quantities have magnitude, which means size, and direction. So add that to the list of definitions that you've already written down today. Pause the video. Okay, we end today's lesson with a little mini test then. I want you to read the key learning ideas that you've written down this lesson. That's that stuff there. Spend 1 minute just going over it, trying to remember it, trying to revise it. Once your minute's up, you can turn those key ideas over, turn your page over, put your book face down, and then see what you can remember. There's a little mini test set of questions that you have to go at. So pause your video for 1 minute and do your revision. Okay, let's have a go at our little mini test for this lesson then. So this is a true or false activity. You just need to write true or false next to the statement or write it down on your piece of paper. If something is false, then just see if you can actually do a little correction. Write down what it should have been. Pause your video. Let's see how you got on then. So a quantity is something you can measure. That is true. Some quantities do not have direction. They are called vector quantities. That is false. Some quantities do not have direction. That bit is correct, but they're not called vector quantities. They are called scalar quantities. Scalar quantities just have size. That is true. Magnitude is another word for direction. That is false. Magnitude isn't another word for direction. It's another word for size. Displacement is the vector quantity for distance when the direction matters. That is true. Velocity is the vector quantity for speed where the direction matters. That also is true. Vector quantities have magnitude, which is size, and direction. That is true. You got all them right. Well done. If you didn't, a couple of corrections to make. You can pause the video and do that now. Otherwise, there we go. That's it for today. Thank you very much. Anything you didn't understand, feel free to rewind the video and go over again. That's all, folks.